Hello everyone, I am Professor Nazma Ahmed. I am from Anjuman College of Engineering and Technology. I have created one open education resource presentation under the guidance of FDB 201X IIT Bombay X. My team ID is 1259_002. And my topic is laws of motion. Today we will discuss about these subtopics. In this we will see introduction, Newton's laws of motion, Newton's first law, inertia and examples, frame of reference, Newton's second law and Newton's third law. First we will see about introduction. We have been studying the nature of motion of objects in the previous chapters. We came across a variety of motions like motion with uniform velocity, motion with variable velocity, that is accelerated motion. The basic cause behind the motion of an object and the nature of motion of an object is force, which is the most important point of discussion in this chapter. The three laws that describe how forces govern motion were described by Isaac Newton in 1687. Newton's laws of motion are three physical laws that together laid the foundation for classical mechanics. So, Newton's laws of motion are based on foundation for classical mechanics. It describes the relationship between a body and the forces acting upon it and its motion in response to those forces. There are generally three laws which Isaac Newton has suggested. They are first law, second law and third law. We will discuss more in detail. First we will see what it defines. First law defines the force qualitatively, second law defines the force quantitatively, and third law asserts that isolated force doesn't exist. This is the image of Isaac Newton. He was the physicist and mathematicist who formulated the laws in 1687. The three laws of motion were described by Isaac Newton in his Philosophia Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, first published in 1687. Newton used them to explain and investigate the motion of many physical objects and systems. These laws provide an extraordinarily accurate description of motion of all material objects, small or large, simple or complicated, on the everyday scale. Next we will see what are the three statements of the Newton's laws of motion. First law, second law and third law. First we will see about first law. So what is meant by Newton's first law of motion? An object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Next we will see what is meant by second law. The vector sum of the forces F on an object is equal to the mass m of that object multiplied by the acceleration a of the object. F equals m into a, where m is constant. Next we will see what is meant by third law. When one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. Next we will see in more detail what is meant by Newton's first law. So what is meant by Newton's first law? When no net force acts on a body, the body either remains at rest or moves with constant velocity. Once a body has been set in motion, no net force is needed to keep it moving. If no net forces act on a body, then the body's velocity does not change, that is, the body does not accelerate. When the vector sum of all the forces acting on a body is zero, or there are no forces acting on a body, it is said to be in equilibrium. That is, if summation F equals 0, the body is in equilibrium. Next, we will see what are the several applications of Newton's first law. Blood rushes from your head to your feet while quickly stopping when riding on a descending elevator. The head of a hammer can be tightened onto the wooden handle by banging the bottom of the handle against a hard surface. A brick is painlessly broken over the hand of a physics teacher by slamming it with a hammer. Another example is, to dislodge ketchup from the bottom of a ketchup bottle, it is often turned upside down and thrusted downward at high speeds and then abruptly halted. While riding a skateboard or wagon or bicycle, you fly forward off the board when hitting a curb or a rock or other object that abruptly halts the motion of the skateboard. So these are some of the applications of Newton's first law. Next, we will see what is meant by inertia. The tendency of a body to keep moving once it is set in motion or to remain at rest if initially it was rest results from a property called inertia. Inertia is the inherent property of material body by virtue of it resist any change of state of rest or of uniform motion. Inertia is not a physical quantity. Mass of a body is the measure of its inertia. If a body has large mass, it has more inertia. There are different kinds of inertia which we will discuss below. They are of three types: inertia of rest, inertia of motion, and inertia of direction. First, we will see what is meant by inertia of rest. The tendency of a body to remain in its position of rest is called inertia of rest. Okay, this is simple. Inertia of motion. It is the inability of a body to change by itself its state of uniform motion along a straight line. That is called as inertia of motion. Next, we will see inertia of direction. The inability of a body to change by itself its direction of motion is called inertia of direction. So these are the three different kinds of inertia, which are inertia of rest, inertia of motion, inertia of direction. Let's see some of the examples which are based on inertia at rest, inertia of motion, and inertia of direction. First, we will see an example of inertia at rest. When a bus or train starts suddenly, a passenger standing inside, it leans backward. This is because the feet of the passenger, which are in contact with the floor of the bus, start moving, but because of inertia, the upper part of the body tends to remain at rest. Inertia of motion. When a passenger sitting in a train moving with a uniform velocity throws a ball vertically upwards, the ball returns back to his hand. This is because during its upward and downward motion, the ball continues to move horizontally with the velocity of the train. Next, we will see what is meant by inertia of direction. When a bus takes a sharp turn towards right, then the passengers standing inside lean towards left. This is because the feet of passengers which are in the contact with the floor of the bus starts turning with it, but due to inertia of direction, the upper body tends to move straight. So these were the examples of inertia at different direction, at rest, at motion, and direction. Next, we will see what is meant by frame of reference. In order to describe the motion of an object, we use a specific origin with a reference system of coordinate axes called frame of reference. The frame of reference may be attached to ground, another stationary object, or a moving object. Frame of reference is classified into two categories: inertial frame of reference and non-inertial frame of reference. Next, we will see what is meant by inertial frame of reference. Newton's law are directly applicable. A frame of reference attached to a stationary object or an object moving with constant velocity is called inertial frame of reference. Non-inertial frame of reference. Newton's laws are directly applicable. A frame of reference attached to an accelerated object is called non-linear frame of reference. So, inertial frame of reference are directly applicable to Newton's law, and non-inertial frame of reference are directly applicable. Newton's second law. If a net external force acts on a body, the body accelerates. The direction of the acceleration is same as the direction of the net force. The net force acting on a body is equal to the product of the body's mass and acceleration of the body, that is, summation of F equals mass into acceleration. Its unit is, the SI unit of force is Newton, and 1 Newton is equals to 1 kg meter per second square. Next, we will discuss about Newton's third law of motion. So, what is meant by Newton's third law of motion? To every action, there is always opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. When one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. If a body A exerts a force F on another body, then the body B exerts an equal and opposite force minus F on body A. These equal and opposite forces F and minus F are called action-reaction pair. Any one may be called as action and the other as reaction. Suppose a man applies a force F on a block placed against a wall, then block in turn applies a force F on the man in opposite direction. The third law states that all forces between two objects exist in equal magnitude and opposite direction. We can also discuss Newton's third law of motion by taking another example. For the block to remain stationary, wall will apply a force F dash on the block, due to which the block gives a reaction force F dash on the wall in opposite direction. So, here is also formed an action-reaction pair. We must keep this in mind that action-reaction pair do not cancel each other as they act on different objects. One example of Newton's third law of motion is rocket propulsion, which is generally based on Newton's third law of motion, which states that to every action there is an equal and opposite reaction.